Hi ladies and gentlemen, I'm Teacher Nondo. Let's do some mathematics by Teacher Nondo. So today the topic we are going to look at the geometric progression, which can be abbreviated as GP. Those who follow me, last time we did the arithmetic progression, abbreviated as AP, under sequence and series. So today we are going to look at the geometric progression. So without wasting much of your time, let's solve this question. So today we are going to look at how to find the sum to infinity, the sum of the GP, the first term, and the common ratio. So today, let's look at this question. So the question reads, the first three terms of the geometric progression are k plus 4, k, and 2k minus 15, where k is a positive integer. Question A, find the value of k. Question B, list the three terms. And question C, find the sum of the 10th term. Finally, the question D, find the sum to infinity. So solutions to these problems, as we all know, for us to find the value of k, we all know that when finding the common ratio, we say T2, which is the second term, divided the first term, which is equal to, or rather equivalent to, T3 divided T2, which is also equivalent to T4, divided T3. It goes like that, so long as the sequence continues. Now, in this case, we only have three terms, which are k plus 4, comma, k and 2k minus 15. Therefore, we are going to say T2 divided T1 is equal to T3 divided T2, where T2 is k and T1 is k plus 4, which is equal to T3 is 2k minus 15 and T2 is k. When we multiply, we are going to have this, okay? Now we are going to group the like terms, where we are going to have 2k minus 2k squared minus k squared plus k, 8k minus 15k minus 60. When we subtract, we say 2k squared minus k squared, we are going to have k squared. 8k minus 15, we are going to have 7k, and 6 to come this way. Okay? So when we reach this stage, we have to factorize. Now for us to factorize an equation, or rather something like this, we need to find the product, the sum, and the factors. Now the product, how do we find the product? We multiply. Okay? We all know that the coefficient of any letter, despite the power, is 1. So the coefficient of k squared is 1. So 1 by 60, we are going to have 60 squared, negative 60. And the sum, we get the middle, okay, so which is negative 7. We don't mind the letter, we only get the number. Okay, so we have the sum is negative 60. Now, when it comes to the factors, what are the numbers that when we multiply will give us negative 60, and when we add will give us negative 7? So here, when we add or we multiply negative 12 by 5 to give us negative 60, and when we add negative 12 plus 5 to give us 7. So these are the factors. So we just get the factors. So these factors represent 7. When you add negative 12k plus 5k, they will give us 5k or 7k. So this is how we bring it. So now we factorize. So you divide this. What is common here is k. K into k, we are going to have k into k squared, we're going to have k. Then k into 12k, we are going to have 12. Here, what is common is 5. 5 into 5k is k. 5 into 60 is 12k. So we have seen that these, which are in bracket, are the same. So just get one of these, and you add this, okay? So we are going to 5k. So we have simplified this, okay? When you reach this, you find the value of k, where you're going to have 5k. K plus 5 is equal to 0, or k minus 12 is equal to 0. When this 5 crosses the equal sign, it will be k is equal to negative 5, or k is equal to 12. And the question says k is a positive integer. Therefore, k is equal to 12. Okay? We have found the value of k. Question B says list the terms of the sequence. So that's the sequence, we have k plus 4, k and 2k minus 15, where k is 12. So 12 plus 4, it will be 16, and k just to be 12, and 2 by 4, 12, it will be 24 minus 15, it will give us 9. So these are the three terms, 16, 12, 9. So these are the three terms of the sequence. We have answered question B. Let's answer question C. Question C says, find the sum of the 10th term. Now, this is the equation that we use, or rather the formula, to find the sum of the GP. Now, one thing that you have to be very careful of, or something that you have to consider, is the value of R. What is the common ratio? If the common ratio is greater than 1, then R comes this side. R will subtract 1. But if the common ratio is less than 1, 1 will subtract R. So this is something that you have to consider. In this case, let's find the common ratio. So the first term is 16, and the second term, okay, we are going to use this formula, T2 over divide T1, where T2 is 12 and T1 is 16. So we are going to say 12 divide 16. Okay, what number can we divide that can go into both numbers? Is 4. 4 into 3, 12 is 3. 4 into 16 is 4. Okay, or it is 0.75, which is the value of R. Therefore, we have seen that the value of R is less than 1. So we are going to use this formula, R 1 minus R. Okay, we continue. We are finding the sum of the 10th term. So we are going to say 10 is equal to S10 is equal to, the first term is 16, which we have the formula says N is equal to A open bracket 1 minus R to the power N minus 1. Okay, the first term is 16 minus this one. When you subtract 10 minus 1 to give us 9. 0.75 to the power 9 to give us this one. When you subtract 1 minus this one to give us this one. When you multiply 16 by this one to give us this one. When you subtract 1 minus 0.75 to give us 0.25. Then divide. Therefore, the sum of the 10th term is 59.2. We have solved question C. Let's solve question D. Question D says, find the sum to infinity. Okay, so this is the formula that we use. Okay, A first term minus. Okay, another thing that you have to consider again when finding the sum to infinity is the value of R, the common ratio. If R is greater than 1, then R, it will be like this. But if R is less than 1, we are going to use this formula. In this case, we have already solved the value of R, which is 0.75, which is less than 1. Therefore, we are going to use this equation. Okay? What is the first term? Is 16. What is 1 minus 0.75? It is 0.25. You divide is 64. Therefore, 64 is the sum to infinity. We have solved all the questions. Let's solve another question. This question came in 2016. Okay? Final exam. The question reads, in a geometric progression, the third and the fourth term are 2 over 9 and 2 over 27. Question reads, find the first term and the common ratio. Okay. So for us to find the first term and the common ratio, we use this formula. We say Tn is equal to A times R to the power N minus 1. Okay, this is the formula that we are going to use to find the value, the first term and the common ratio. Now, for you to find the value of Ra and R, we have to derive two equations where we are going to say Tn is equal to this. Remember, in the question we've been given the third term and the fourth term, which are 2 over 9 and 2 over 27, the third and the fourth term. Therefore, we are going to say T3, which is the third term, is equal to A times R to the power 3 minus 1. When you subtract 3 minus 1, it will give us AR to the power 2, okay, over Chi. The third term we have here is 2 over 9. So we are going just to bring it here. Then we want to find, we make A the subject of the formula. Chi, we have to find the first term. So for us to make A the subject of the formula, we divide both sides by R squared.